Now let's look at how Java achieves object-oriented programming. Like we said in previous sessions, an object is an encapsulated block of data and the code. It exists in memory. It performs a specific task. And it also has two general capabilities, the data and the operation. Data is known as fields or attributes. Operation is known as methods. We have already used the following objects before. We have the scanner object, random object, and the print writer object. For example, for random object, once we create a random object, it has actually some like seed, random seed inside it for each object. But you won't be able to change the inside seed. You can only call some methods from the object to get what you need, the random numbers, right? This is an example of how the seed, the operation detail is hidden away from the outside user. The outside user can only access the functionality through the programming interface. So these are the objects we have been already using. When the program needs the service of a particular type of object, it will create that object in memory and then call that object's method as necessary. We have been using class, and whenever we create a new Java program, we always create a new class. But what is a class? A class is a code template that describes a particular type of object. It specifies the data and the action of that object by writing Java statements. You can think of a class as a code blueprint or template that have the Java statements that specify the data and the action of that object. When the Java programming is running, it can use class to create objects. Java virtual machine, once it sees a request to create a new class, a new object, it will load the class definition. And based on the class definition, allocate a chunk of memory in which you will store the class attribute, the object attributes, and the methods. Each object that's created is called an instance of that class. You can create as many instances as you want of that class, as long as you have enough memory space for these objects, right? So here is an example. We're already using this code for a while. Scanner keyboard equals new scanner. So the new keyword is used to tell class, to tell JVM that it's going to create a new object instance. The class name after new keyword is what JVM will start looking. If Java Virtual Machine cannot find that class, it will give you an error. And you need to import that class from wherever that class resides in. So once Java Virtual Machine can find that class definition, it will allocate memory, create the object by specifying what attribute and the code and message belongs to that object in that chunk of memory. This is the creation of an object. But once you create the object, you also need to assign the address, the memory address of this object to a variable so it can be used later. Similar things happens to other objects, like random is similar, the same new keyword, just followed by a different class name. And remember, when you use random, you need to import a Java class, or when you use scanner, you need to import Java utility package. All these are done to help JVM finding the class definition and create the object. Once the object is created, once the object instance is created, you assign the address of the memory chunk to a variable so that you can reference it later on. And so this, let's see, take a look at the object demo.data. So this is the object demo.java file. We create a scanner, we create a random, we create a print writer, and we do all the things we have been doing so far. And you can see that it's not so easy. When you have one object, one class is easier to understand. But when you have multiple, like so many classes, chapter 10, chapter 8, when you have so many, chapter 6, when you have so many classes all listed like this alphabetically, it will be very difficult for regular readers, normal human being, to understand what they are and how they are related with each other. That's why we have a standard graphical tool or graphical standard called UML, Unified Modeling Language, to describe classes, the class definitions. A UML consists of multiple rectangles. Each rectangle is one class, is one class definition. Inside the UML rectangle, there are three chunks, three blocks. The first block is class name. The second block is a list of all the fields, and the third block is the list of methods. For example, if we want to define a rectangle class, each rectangle should have a length and width. This is class name, this is field, and once you have the length and width, a rectangle is defined, you can set and get length and width, and you can also get area. Thus, this is the UML diagram for one class, and you can have as many as possible, and you can also have lines between them to indicate their relationship.